Hi, I'm Bethany, and I have conducted an experiment with two of my classmates over studying chemical reactions. So today we've prepared a video for you so you can see what we did throughout this experiment and what we learned from it and how it can apply to even you. The purpose of our experiment was to determine solubility rules for cations and anions by carrying out a series of chemical reactions and then observing those changes and then knowing when the chemical reactions take place. You can observe four changes. There can be a gas formation, a precipitate formation, you can have a color change, or a temperature change. If any of those four signs occur, you know you've had a chemical reaction. This was an experiment that we conducted within our chemistry laboratory. We also have a class accompanying that, and that is just our chemistry lecture. Within this lecture, we are learning how to balance chemical equations in false situations pre-created by the creators of our chemistry schoolbooks. Lab is helpful to us because we get to see how to apply these chemical equations and reactions into situations that we are conducting as we do it. But don't get me wrong, chemistry can be used in just everyday use also, such as on your nutrition labels of all the foods you eat, you can notice you'll see things like potassium on there, you'll see sodium, and many others, and all those are elements of the periodic table. Also, you can see a mixture or a compound, you can see that in different things of what you eat or drink. One instance could be water, which is not just one element, but two different elements combined. 200 atoms per every oxygen atom. You may have heard it referred to as H2O. So in this experiment that we were talking about, we've taken many different elements that may be combined or already combined, and we've put them together to see what kind of reactions have occurred.
Hi, my name is Rosemary Flores. Part A, we were to combine two compounds from a list that was given to us. These two aqueous solutions that we decided to combine was sodium phosphate and zinc sulfate. We combined 5 drops of each into a clean, clear test tube. The results were sodium sulfate and zinc phosphate. Through the observations, we can clearly tell that there was a chemical reaction because a participant formed and there was a change from a clear solution to a cloudy solution. In part B of our experimental procedure, we combined aqueous solutions with metallic elements to see what the product would be. This was to determine the relative reactiveness of each of these elements. The first one we did was zinc and sulfuric acid. There was a chemical reaction, there was bubbling and a temperature increase. The second was zinc and copper sulfate. There was a chemical reaction, the zinc turned black and there was a blue clear solution. In part 3, we did copper and sulfuric acid, which when combined, the copper dissolved, which made it a chemical reaction. In part 4, the reactants were copper and zinc sulfate, which had no chemical reaction. Part 5, copper and magnesium sulfate, again, no chemical reaction. 6, magnesium and zinc sulfate, no chemical reaction. And 7, magnesium and sulfuric acid, which there was no chemical reaction observed.
Hi, I'm Nikki. For part C, at the end of this, we will discuss our results and conclusions with the net ionic equations. For part 1, we will be reacting Mg or magnesium with HCl solution. First, transfer a 0.5 centimeter piece of magnesium ribbon into the test tube. The ribbon is a black with specks of white. Second, measure 2 milliliters of 0.1 molarity HCl solution. This will be a clear and colorless solution. Third, pour HCl solution into test tube with the magnesium. To observe this reaction, we got no chemical reaction. For our second part, we will be reacting PbNO32 solution with Ki solution. Transfer 10 drops of 0.1 molarity PbNO32 into a test tube. This will be a clear and colorless solution. Next, transfer 2 drops of 0.1 molarity Ki into the PbNO32 test tube. This reaction will result with a cloudy yellow neon solution. Discard the test tube contents into a specified container. For procedure 3, we will be reacting HCl solution with NaOH solution. Caution, both NaOH and HCl solution are toxic. First, you will measure 2 milliliters of 0.1 molarity NaOH. This solution will be clear and colorless. Then you will transfer the NaOH. Add 1 drop of phenolphthalein indicator solution to the NaOH. Observe this reaction and it will be a bright neon pink solution. Measure 3 milliliters of 0.1 molarity HCl. Add 1 drop of the phenolphthalein solution to the HCl. Cause a precipitate to form and a cloudy appearance with orange tint on top of the solution will appear. Pour 1 milliliter of this HCl solution into the test tube containing NaOH solution. 7th, you will need to add remaining HCl drops until the color changes. We'll observe this reaction and discard into a specified container these contents. Part 4, we will be reacting FeCl3 solution with NaOH. Transfer 1 milliliter of 0.1 molarity FeCl3 solution into the test tube. This will be a cloudy orange solution. Transfer 1 milliliter of 0.1 molarity NaOH. This will be a clear and colorless solution. Transfer the NaOH solution into the FeCl3 solution test tube. Observe this reaction. The bottom is dark orange and the top is a light cloudy orange. Discard the contents into the specified container. For part 5, we will be heating NH4 to CO3. Transfer enough NH4 to CO3 to fill the end of a microspatula into a test tube. This will be a white solid rock. Place a piece of red litmus paper on a watch glass. Third, you will place 1 drop of distilled water onto this litmus paper. Next, you will observe the reaction and it should be blue. Grasp the test tube containing NH42CO3 with the test tube holder and hold this test tube at a 45-degree angle. Strongly heat the bottom of the test tube with a Bunsen burner flame and carefully observe both the solid and the test tube walls near the opening end of the test tube. You should see a gas form. Holding the mouth of the test tube 15 centimeters or 6 inches from your face, carefully fan the fumes towards note the odor of these vapors, which for us they smelled terrible. Position the watch glass and litmus paper so that the moist paper is next to the test tube mouth. Observe this reaction, which you should again get blue. Record on your data sheet your description of what happened to the solid NH42CO3, the insides of the test tube, the odor of the test tube, and the color of the litmus paper. For us, the rock broke down and turned to a gas. It smelled terrible, and it was blue on the litmus paper. Lastly, you will discard the contents into the specified container.
I'm going to go over the ionic equations and the reaction types that Nikki just went over. First, for each one we have complete ionic equation. So you see for part 1 we have the Mg solid plus 2H plus aqueous plus 2 chlorine negative aqueous reacts to produce Mg2 plus aqueous plus 2 chlorine negative aqueous plus H2 gas. The net ionic equation for this Mg solid plus 2H plus aqueous to produce Mg2 plus aqueous plus H2 as a gas, and that reaction type was a synthesis reaction. Then for part 2 we had Pb2 plus aqueous plus 2 NO3 negative aqueous plus 2 Ki positive aqueous reacting to produce Pbi2 solid plus 2 Ki positive aqueous plus 2 NO3 negative and aqueous. And then the net ionic equation was Pb2 plus aqueous plus 2I negative aqueous, and the products was Pbi2 solid. And that was a double displacement reaction type. Then for part 3, we have Na positive aqueous plus OH negative aqueous plus H plus aqueous plus chlorine negative aqueous reacting to produce Na plus aqueous plus chlorine negative aqueous plus H2O liquid. And then that net ionic equation, H plus aqueous plus OH negative aqueous reacting to produce H2O, the liquid. And again, we have a double displacement reaction type. For part 4, we have FeCl3 plus 3NaOH reacting to produce 3NaCl plus FeOH3. And this net ionic equation is Fe3 plus 3OH negative reacting to produce Fe3OH. And that again was another double displacement reaction. And then for part 5 we have NH4 2CO3 reacting to produce 2NH3 plus H2O plus CO2. And then for our net ionic equation, you see we have the same equation because there was no repeating elements or compounds. And this was a decomposition reaction type.
To compile our video, here are our references, our chemistry textbook, and the Experiment 5 Studying Chemical Reactants handout provided from Dr. Mullins.